Guys, welcome. We're hosting a session about the proposal that RockX issued. This time around, it's going to be a different format because we've already hosted RockX in the past. So you guys can check out the information below. We'll link it to the previous call. But it has been a while and a few things have changed. By the way, big shout out, congratulations for the Lido integration. Zuling, I'll give you the stage to give us a few updates before we introduce the rest of the panel and before we dive into the proposal and talk about the heavy lifting, difficult questions. So take it away.
Sure. Hi, everyone. Yeah, great to be here again. So again, for some of you may have watched the previous video. So my name is Julian. So I'm from the RockX team. Of course, for this proposal, we are joint force called as the X Matrix Labs. Just to give a few updates, what we've been up to. So for RockX, we have been continuing to grow to serve institutional clients, particularly in Asia. So recently, we have just signed a partnership to provide staking services for some of the ETP products listed in Europe. And on the tech side, we have, besides validators, we have launched access nodes that for developers and institutions to tap into on-chain data. On the tech side, we are continuing looking at liquid staking. So there are some interesting products we're working on for both ETH and other protocols. So the main goal here, is to serve more clients and also to provide a robust infrastructure for them. This is also, the reason we joined ssv.network at the very beginning, and we started to look at MPC to even enhance that security. And end of late last year, that's where we see the marriage of SSV and MPC together to actually complete the whole puzzle. That's how we started this proposal. And together with me, we have Guanglei and also Kai from the labs.
Oh, sorry, I was muted. I was about to say, great introduction. I'll introduce from our end. We have Adam with us and Alon with us, both co-founders. We also have Matt with us, which is pretty funny because we just made the connection that you both are in Singapore. So it's good that you guys are meeting via Zoom link, but it's good to know.
Yeah.
So we have a really full house today and a lot of questions. We brought Alon for the difficult technical questions. We brought Adam for the overview questions. So without further ado, I'd really love to get cracking, jump right into it. Adam, take it away.
I'll try to ask a few of the questions. Obviously, a lot of the deep tech, deep dive related subject will be covered by Alon. But I'd love to get started with a sort of explain to me like I'm a 3-year-old type of brief over, what is exactly DKG and what is the implementations that you guys are planning to bring to the SSV network. That will be, I think, a good starting point for us because a lot of people are not very familiar with the tech and don't understand the value proposition. So, for the average guy, try to sort of break it down.
Mm-hmm. Yeah. So I'll try to take a first crack on this. And yeah, so from our understanding of the whole vision of SSV is in fact to allow anyone can join and as a node operator for a ETH for a various number of ETH validators. And in this case, it's not just a single node operator that takes care of one validator, but it's multiple to multiple, right? So actually, this is kind of like a playground that you want as many people to join in, and also, collectively, they perform the work together. So this involves 3 components, in order to do this. What the current SSV team has been working on is the coordination for the multiple people to work together on the signing. Yeah, so this is super important because this is a very hard coordination that you need multiple people to work together and also to interact correctly with the Ethereum network, in this case, the beacon chain. But however, we are taking a step back, so before the multiple people to work together, we want to ensure one very crucial aspect here is that, before we are handing over all the private keys to this group of people, nobody has ever seen the full private key. So that's where, the DKG part, or we call it decentralized key generation, works. So the idea here is that, before we grant all those people to perform the coordination work, they only got a slice of that private key, and nobody has ever seen the complete key before. So by doing this is the way for us to allow many, as many as possible people to join the network and perform the work securely. And another aspect that we also think, is super crucial for SSV is that SSV is gonna be a fluid network, meaning that, there will be people joining anytime as node operators, but there will also be people become offline or become, or they decide to exit the network. Yeah. So this means, this network cannot be a static one. We need to allow that the existing people who are holding the keys can pass on the key fractions to someone else, or even just for security enhanced purposes. For a time period, there should be a reshuffling of the key shards. So in this case, the key shards are always, nobody knows, what exactly they're holding, and it's safe to get new people in and let people out. So that's what we're trying to do here, to use multi-party computation to support the complex coordination within the SSV network, and also ensure that nobody has the full private key and its fluidity as a network.
I would also add that distributed key generation opens up different use cases. It's basically a very advanced key management component of SSV. Today, the way SSV works is that somebody generates a private key, usually the owner of the validator. That generation can be offline in a very secure hardware, but ultimately it needs to distribute shares to the operators. And of course, in that way, we can allow existing validators to come onto the network and use the network in a distributed way, with a much better infrastructure than what currently is available. But having the ability to generate in a distributed way the key, which means that there's no single point of failure, no single entity holding the actual full key. It opens up use cases like decentralized staking pools and so on and so forth. And I think that's something which is very, very much in the interest of a lot of different projects. And a lot of different projects really see that as a really good advancements forward in terms of decentralization and so on and so forth. So the importance is also, it's not that just technical, but it also really opens up use cases which are unavailable right now.
Right. So sort of just to try to break it down and make sure, everybody's on the same page. Basically, the entire, validator key related process can be generally divided to three main buckets. So the first one is the creation of the key. The second is the operation. And the third is ongoing management. And SSV network, the protocol in its current form, is kind of dedicated towards the operation part. So those nodes that received key shares are actually working under consensus in order to attest and propose on the beacon chain and manage the validator, duties ongoingly. What you're proposing is also to create a distributed, decentralized component around the creation of the key itself, right? So no single entity is ever exposed to the actual secret. And then the key shares are distributed once they are created, which adds another layer of decentralization and security for the key creation process. which leads to the second part of which is the operation side of things. And then later on, there is obviously the key management where you want to maybe reshuffle the keys between nodes in the network, or alternatively actively switch different nodes that you originally created or chose in your original validator, distributed validator setup. Is this sort of a macro view of the idea that we tackling here?
That's exactly the point here, Adam. Yeah. So to summarize, the first thing here is to enhance to avoid a single point of failure at the very beginning of key generation, and as a result, this makes the whole network much more secure, and also like Alan described, this opens up new possibilities of smart contracts interaction or any kinds of DApps, to work with, right? So this is also an idea that we have also explored with other people in the past. What we have understood is that, for a network like SSV, there could be multiple use cases. There will be institutions would love to use it just, for their internal enhancement. But there could be a decentralized way that maybe in the future we want the multiple validators to be, let's say, secured by some kind of verified players, but also to get some of the hobbyists to get in, right? So this encourages like amateurs and also different kinds of people to work together. So in this kind of cases where not all the players do not know each other, that's why it's really crucial to avoid a private key to be exposed to a single party. That's why in this case the DKG is super important to enable that kind of setup.
Perfect. So I think a good segue for us would be basically two questions. One is, obviously, the ssv network protocol, you can build a lot of different implementations on top of it. We mentioned staking pools and staking tokens and insurance schemes, and there are different proposals coming in from different teams to create different implementations. Why is DKG sort of the technology or the implementation that you guys decided to work on? This is the first question. And the second part of it is, why do you think that you are the right team to take this forward and make DKG on the SSV network a reality?
Mm-hmm. Yeah, sure. So to take the first question, as a team, because as X Matrix Labs, we do not focus on the applications, the DApps. We actually focus on secure key management and also zero knowledge. This is because this is what we believe in is needed in this whole space. Since that more assets are being either staked or managed, it's really important that we do not want to leave a private key, a single private key exposed. That's why DKG, we think it is the only way, the viable way to deliver that vision for SSV. Yeah. In terms of why we are the right team. So first of all, as the labs, we have already implemented a private version of MPC. So MPC involves the DKG part, the resharing, and also another different type of signing. But that is more for, it's not for SSV, that was more for asset management. So we have experience of implementing it. And given that, we have also been running participating in the SSV testnet since last year. So we also understand how SSV works. So I think the crucial part here is that, besides implementing the DKG part, it's also important that the integration with SSV to be successful. So this is the part where we think our experience will also play an important part.
Perfect. This is very, very true. I mean, you guys have been very supportive of our work from the get-go. You've been running a node, I think, ever since we started with the public testnet. So thank you for that. The support, your support is very crucial for the network so far. And I think it's apparently very crucial for the network network's future as well. We touched this a bit in the beginning of the call, but I'd like to maybe dive into it a bit more. What is your idea of the implementation side of the technology? So let's say now there is the ssv protocol and there is a DKG key creation scheme already live in the network. How will people use it? How are you guys planning to use it? And how does it link to sort of your company's vision or your ideas, development ideas for the future?
Mm-hmm. Yeah. Maybe I'll just take the vision part first, then I'll leave the ground to Guanglei to walk through some of the technical details on our proposal. So as the labs, making MPC work and making DKG work is our goal, because we really believe this will be a more secure technology in the market, particularly for crypto. Yeah, that's why our goal here is that, okay, we would like to build open source MPC that is linked to a real use case. So in this case, we see that ssv is the perfect match. Yeah, and along the way, we'll be more than happy to maintain and also evolve the technology, together with ssv. So that in the future, if other teams need the MPC, they can also leverage on the open sourced codes. Okay, Guanglei, if you could share the proposal, let's go through that.
So I will run through the proposal about the high-level design. So essentially, we will handle the MPC layer, which sits in the middle. If you see the diagram, it will actually interact with the smart contracts, which acts like the governance part of the whole ecosystem. And it will also interact with the ssv network. So what happens is the DKG or the MPC layer will take the input from the smart contracts, which means that the DAO users or the validators, they assign operators. So the MPC layer will listen to the events from the smart contracts and will check whether there is a need for generating new set of keys for the set of operators, or is there any change in the operator set so that the resharing is required. And of course, when the operators are producing the blocks, they will have to use the signing protocol to sign the blocks. So the signing part is now implemented already in ssv code. So what we will add is the DKG and the resharing. So in this case, the DKG and resharing will only be a collaborative work among the operators. What is required from the validator is only like a trigger or the command to tell the operators to start the DKG or start the resharing. So in this case, there's no need for the validator to custody their own private keys, which is like a single point of failure. And also it requires the validators to carefully custody their private keys. Also, maybe if they are using some internal processes, I think that will be a challenge for the validator. So now we lifted that challenge by replacing all the key custody with the MPC. In this case, all the operators will jointly generate the keys, but each of them will have a share of the key, but all the key shares will be kept in private, and also the final key is derived from all the shares. In this way, no one really has the access to the actual private key, but the set of operators can use their shares to produce the signature for the respective keys generated. So essentially, what we are implementing is the DKG and resharing. besides the integration. So for the DKG, at its core is a Feldman VSS done by each of the, let's say there are N operators. There will be N Feldman VSS shares, VSS protocol, so that's each of them will select one random number, and this random number will contribute to the final private key generation. And there are 3 steps involved in this process. The key here is to ensure that no one is able to take advantage of the number they have other operators have already selected, so that we can ensure that no one can control the private key. So yeah, so the resharing is essentially somewhat similar to DKG. The only difference is that it won't need to generate a fresh key, but it will generate new shares for the original private keys. So the actual algorithm is slightly different. So this will just require the threshold of M participants. Because they have their shares, using their shares, they can redistribute the private key into another set of operators. Yeah. So for the signing protocol, is essentially just a threshold digital signature scheme. So and also it's provided by BLS out of the box. So what happens is M of the N operators, which they have a key share each, they will sign the message, and someone can aggregate all the shares of the signature and produce the final signature corresponding to the public key. Yeah. So I think that's the main design. About the project plan, because most of the MPC are actually implemented in Rust, and also what we have already, some of the MPC libraries are also implemented in Rust. So we decided to implement the first version in Rust, but we will provide a Golang wrapper so that we can use the wrapper to integrate the MPC layer into the ssv network. So, and also we will also handle all the integration of the MPC layer into the ssv network. So the timeline is we aim to complete the beta version in 4 months. Yeah. So about the compensation, I guess it's quite standard. We are looking for like 200 USD, and it will be the payment will be made in three steps. First one will be 30%, and second one will be 40% upon MPC working started. So, and the final 20% will be after the integration of the code. Yeah.
Perfect. Thank you for that. So basically, what you guys are looking at, assuming hopefully that the proposal will get passed, you guys will be able to, get to work almost immediately and provide a beta version of the DKG in 4 months time, right? Can you walk us through sort of support and ongoing maintenance for for that component of the network? I know it's important also to make sure the code is currently being ongoingly being worked on. So is this something that you also have in plan?
Yeah. So on that aspect, we are fully aware that SSV is also an evolving protocol. That's right. For this proposal, what we're aiming for is actually a working prototype and also successfully integrated with the current SSV network. So, after this once this is delivered, this means that SSV network as it is now will be working smoothly with the MPC component. For the ongoing maintenance, this is the part that we still need to probably work closely with your team to understand, what are the major upgrades and also what's the implication, towards our part, right? So we're happy, to do the maintenance if this is more of a minor changes, but of course, if this requires a major upgrade, that's where probably we'll come back to the DAO and list out, okay, what are the major changes and what kind of support we need. Yeah, but definitely, we're here. We would like to see the success of this whole project. Yeah.
Makes sense. I just want to sort of reiterate one thing. I think Lon posted a blog post 2 months ago or so titled Road to Mainnet, and DKG and that component of the network is definitely one of the key components that we see that are in need of implementation before or right after we hit mainnet. So this is definitely something that if you won't work on, we will need a different team to implement this, or we would do it ourselves. So it's super important, to have an experienced team like you guys coming in and doing a lot of the heavy lifting when it comes to DKG. That's pretty awesome, and it's sort of pretty important to make the distinction between a component like I don't know, an application layer, like a staking pool based on SSV, which is super important as well. But you can have several implementations like that, and we are seeing different teams submitting applications for building that type of use cases. But DKG is definitely something that is sort of core to our efforts moving forward. So super excited for this to go through and to see DKG live on the network. Anything else you guys would like to mention? Alon, anything else you want to add?
Yeah, I think that in terms of the community, I definitely think that the grant payment stages is important. I think that in terms of technical discussions, it might be a good idea to have like a really, really high level overview of the flow we think the integration would look like, just to kind of set and sync between everyone. And I think those are kind of the last things I think before we can move forward with the proposal itself. I think the main focus here is really the integration into SSV. DKG, of course, is not a new technology. We're not inventing the wheel here, but the idea is to take a solid implementation and find the right way and the right flow to integrate into SSV. And I think that what will make it successful or not successful. I think that's really the focus. Mm-hmm. So I would love to see, and maybe I'll draft something with you guys, kind of a very high level or flow of how we think it might be integrated into SSV, just to give the idea to the community. And I think that once we have that, I think it's really a good time to move down to the proposal, the voting stage, and leave us enough room for to vote and then start implementing towards the mainnet readiness point. Yeah.
I think yep. If you have any more comments, anything else you guys would like to add?
Yeah, I guess this is a typical community call, because we're talking so much into the tech, right? So it's less about like exciting applications, but here we're talking about something that is a substantial component to SSV, that fits into the roadmap. It's a little bit dry as well, because it's a lot of cryptography and also engineering work to make it happen. But we just want to just to call for the attention from the community. Again, this is the hard part, but this is definitely a highly needed part. to be integrated with SSV. Yeah, so we would like to take that challenge.
I agree. I think that as we kind of mentioned before, and again, it's highly technical, but I also think that hopefully we stressed out why it's important. It opens up the possibility to have other use cases which are currently just not available. Think of it as, if I need to compare it to the Ethereum world, think of it as adding new features into the solidity part of Ethereum, right? The Ethereum itself doesn't change, but once you add different features into the solidity part of Ethereum, you open up different possibilities for developers to come in and do stuff which were otherwise not really possible. And I think that advanced key management and key generation protocols are really, really crucial for that part. And I definitely know that projects like Lido, for example, are definitely waiting for stuff like that in order for integrate with SSV. And so I see this as a crucial component. And I think that, having the implementation going forward, starting testing it out and so on and so forth is really, really important.
I think that just to kind of wrap it up, for the people who are less familiar with the technology and cryptography and the more techie side of things, the average person in the crypto space, in the Ethereum staking space, is obviously very much into staking pools, solutions like we mentioned, like Lido, and obviously staking tokens and the rest. DKG essentially opens a lot more optionality and possibilities and functionality for teams that will later on build the next generation of staking pools, which will be based on protocols on the SSV network or protocols like the SSV network. It's a critical component in making the idea and the vision of truly decentralized staking pools in the Ethereum protocol a reality. And I think this is something that concerns everyone, from the average at-home staker that stakes 1 ETH all the way to the big institutions. It creates more functionality, better security. It's an overall public good for everyone involved in the crypto Ethereum space. And this is super exciting, even though it sounds a bit dry, as you mentioned before. I think it opens up a pretty rosy future when it comes to the next level implementations when it comes to staking services in the Ethereum network. Perfect, guys.
Absolutely.
I think this kind of wraps it up. A good sort of final question would be, how can people reach out and ask you questions? Obviously, the forum is a good way to interact with your team. Any other things that you'd like to point out in terms of interacting with you, asking you questions, knowing more about your service and your teams and your core capabilities? Now is the time. And and final comments if you have any.
Mm-hmm. Yep, sure. So definitely please shoot any questions, whether this is a community related or technical question on the forum. So we'll definitely address those. Get to know more about us as a staking service provider and also a research team. You can go to our website, rockx.com. We are always there, to chat on our intercom.
Perfect. All right. This was great. Thanks a lot for everything you did and everything you will do for the network. And excited to see this get started. The vote will be probably open in the next week or two, whenever you guys are ready, obviously. And and we'll try to create more awareness for people to jump in and voice their opinion and hopefully vote on your proposal.
Thank you, everyone.
Yep. Sounds good. Yep.
Thank you.
All right. Thank you, Alon.
Bye, guys. Thank you, everyone.
Okay. Yep. Thank you.